Those of you that just got here, happy Tuesday. Happy Tuesday. Welcome. Hope you had a great weekend. Those of you that were zoned out, maybe didn't hear me in the beginning. Happy Tuesday. So just a reminder, time is running out. We have less than 2 weeks left of school. That's great news, but some of you, it's like horrible news, like, oh, I need to catch up. You can still catch up. It's not too late. Just let me know. Send me a message. All right. What do we see here, guys? What can you identify? How many parts did you identify? So many things going on here. So just yell them out in the chat. Circle. Yes, we can see a circle. What's the name of the circle? That's good. So that's the first thing we see. We see a circle. What's the name of the circle? It's also a place where you can get gas and some refreshments and stuff. What's the name of this circle? How do we name circles? Come on, guys. This is basic. This is 4th grade math. How do we name a circle? It's the first thing I taught you in your last notes. Right over here. How do we name a circle? How do we name a circle? Circle P, Circle K, Circle K, yes. You can either put Circle K or you can do the little symbol for circle and put K, Circle K. Right? Circle K. Very good. Just and yes, you can get gas at a Circle K and some refreshments. Good. What else do you see in here? What other parts of this circle do you see? So that's a good start. Oh, yeah, since that we call that K because that K is the center of the circle. Very good. K is the center of the circle. Right? That's the definition of a circle, right? It's an infinite amount of points, or all the points that are the same distance from another point called the center. So all these points around that make the circle, all these points form together the circle. They're the same distance from that center. And the distance from the center to the edge is called the radius, like someone said in there. Okay, give me a name. There's 3 radii here. There's 3 radii. Remember, radii is the plural for radius. Someone give me one of the 3. There are 3 radii here. Give me one radius. No, a radius is a segment, not a point. A radius is a segment. You got to give me the segment. KL, very good. So this is a radius right here. KL is a radius. JKL, that's 3. That's too many letters. Give me 2 letters. Give me a segment like this one, KL. KI, that's another radius. And JL. JL is not a radius. JL is not a radius. JL is right here. That's not a radius. Radius goes from the center to the end of the circle. From the center to the end. From the center to the end. KJ, very good. KJ. KJ. Segment KJ is also another radius. Okay, so Mario brought up JL. That's not a radius, but it is something else. What is it? It's a chord. Very good. It's a chord, right? So if you have if you have a segment where the 2 endpoints are on the circle, that's a chord. It's a chord. HI is also a chord. Very good. We have a chord right here. HI is also a chord. Oops, I spelled chord wrong. CHORD. There you go. Good job. All right, what else do we see here? What about this one? What's GJ? What's GJ? What do we call that? It's outside of the circle, so it's not a chord, it's not a radius, but it does touch the circle at one point. It's a segment. Sometimes it's a line. It's usually a line, but this is a segment that's touching the circle at one point. It intersects the circle at one point. That's called a what? What kind of segment or what kind of line? Tangent. Very good. That's a tangent, right? When a line outside of a circle or a segment outside of the circle touches the circle once, intersects the circle once, that's a tangent. And the point where it hits the circle is called your point of tangency, right? Tangent has the point of tangency, duh, right? The one point where your tangent line hits the circle is called your point of tangency. Very good. What else do we see here? Diameter, JKL, very good. So from here, diameter JL, right? From here to here is your diameter. Very good. Right? Diameter goes through the middle. It goes all the way across through the middle. It's two radii, right? If the diameter all the way across is 10, that means the radius is halfway. It's 5. So a diameter is 2 radii. Good job. What about, no one has said this, what about GI? HI, yes, HI was a chord. Just from here to here was a chord because the endpoints were on the circle. But what about GI? What about from outside the circle to here? What kind of what kind of segment is that? It starts outside the circle and it hits the circle twice. It intersects the circle twice. What is that called? It's not a tangent. Remember, a tangent is the one that hits it once. Yeah, the one that hits it twice is called the secant line or the secant segment. Very good. Okay, so we did all the segments. Let's see if you guys remember. What would this be? What would this be right here? That's a semicircle. Very good. It's an arc, right? But it's an arc that's half of the circle. It's a semicircle. Remember? An arc that's half of the circle is a semicircle. And if you notice, we also have one right here. That's also a semicircle from here to here. But we have two other kinds of arcs. What are the two other kinds of arcs we have, guys? There's two other kinds of arcs. Right? There's an arc that's small, that's less than 180 degrees. That's called a minor arc. There's an arc that's larger than half, that's more than 180. That's a major arc. Right? So greater than 180 degrees is a major arc. Smaller than 180 degrees is a minor arc. And one that's exactly 180 degrees, exactly half of the circle, is a semicircle. So we have three kinds of arcs. So can someone tell me a minor arc? Someone tell me a minor arc that you see. Remember, minor arc only has two letters. Li is a minor arc. Perfect. Li. So if we look here, arc Li is a minor arc. And a major arc, let's see. Let me get it. I'm trying to get, I know we're getting a lot of colors on here now. Let's see if I can get a different color. JKL. So if we go here, no, K can't be part of an arc. The arc has to be on the circle. K is the middle. JHI. JHI is a semicircle, right? JHI we said was a semicircle, right? Because it's half the circle. JHI, so JHI, arc JHI is a semicircle because it's 180 degrees. It's exactly half. How do you know it's half? Because it connects to the diameter. Diameter's half. Cuts a circle in half. JH is JH, that's a minor arc, right? That's a minor arc. We already did a minor arc. Can someone tell me a major arc? Remember, minor arcs have two letters like this. Li, JH. JL is another minor arc. HI is another minor arc. Major arcs have three letters like, how about JH, JHL. JHL, that's a major arc. JHL is a major arc. So we can say arc JHL is a major arc because it's bigger than half. It's bigger than 180 degrees. All right, lastly, the last thing I want you to identify is, what is this? Oh my gosh. What is this angle right here? What is that angle right here? What kind of angle is that? This angle right here. That's in the center of the circle. Remember, there's two kinds of angles inside of a circle. Yes, that's a central angle. So that would be a central angle. And how do we know it's a central angle? Duh, it's in the center. And then we have these kind of angles right here. Let me get a different color. I'm running out of colors. This angle, and this angle. What kind of angles are those? Right? This angle right here, this angle right here, and this angle right here. Right? These angles right here. What kind of angles are those? It's not a central angle because it's not at the center, but those are angles that are on the circle. Inside, but on the circle. What are those called? What are those angles called? They're not central angles because it has nothing to do with the center. They're on the circle, but they're inside. Of course, they're still inside the circle, but they're not in the center. They're on the circle. Those are called what kind of angles? And this is the last thing we'll talk about. These are blank angles. And if you forget, look at your notes. You guys have notes from before. You can look at those. What kind of angle is that? That isn't at the center, is not a central angle, but it's still inside the circle and it's on the circle. It's called a inscribed angle. Very good. An inscribed angle. And that's what this is, and this is. It's on the circle, but it's not in the center. All right, good job. Good job. I think we got most of them. Just a little hint. This was part of your homework that's due on Thursday. So we did the first part of your homework. So you're welcome. You're welcome. So homework is due on Thursday. And we did the first part, naming some parts of the circle. Okay. All right. So we do have some new notes. We are going to continue the circle talk. And so, again, let me remind you, go to your course, go to our course, period 14. Click on that. And if you look down here, we have week 20. So that means next week is the last week. Next week is week
21.
Yep, week 21. So we're in week 20 this week. So if you click on that folder, you will see three things, okay? Just like we always do. You have the notes. Right? I know it has a due date. These notes are not an assignment. I still have students turning in this for no reason. There's nothing to turn in. These are notes. The only reason I make it an assignment is because some of you use Kami, and the only way I can make this PDF Kami-fiable, right, to be able to be used with Kami, I have to put it as an assignment. So it's an assignment. It says it's due today, but it's not. It's 0 points. It's ungraded. It's not under any category. But the reason I do that is so you can click on it. And then when you go on here, when you click on it, you'll see next to view, if you are on Chrome, you will see open with Kami. And you can open with Kami and you can write on it and save it. Okay. If you turn it in, I will do nothing with it. I mean, it doesn't hurt to turn it in. I'm not mad at you, those of you that turn it in. If you turn it in, that's fine. It doesn't do anything. But it's just, I'm just letting you know it's not an assignment. Okay. You also have the notes solutions. So again, we don't always go over all the examples on the notes, but I do give you the solutions every week. So you can always look at the answers to all the stuff we're going to do in our notes, because we don't go over all of these. So this is good practice. Like, let's say we don't do number 6 and you're like, I want to try a practice problem from class. Let me try number 6. And then you try it. And then you come to the note solutions and you look to see if you're correct or not. Okay. So the note solutions are there. And lastly, the homework is there. Yes, that has a due date of Thursday at midnight or 11:59. We did the first part of the homework. It's all about area and circumference. Okay, so all those three things are there. One of your last homework assignments. Okay, make sure you do it. Make sure you start it today. We're going to talk about area and circumference today. Make sure you start it today. Okay. Any questions on that? All right, so I'll give you a minute to take out your notes, and it looks like this. It should look like this. So take it out, open up in Cami, print it out. So I know some of you print it out or just write it on regular notes. That's fine. Really simple lesson. It's stuff you've learned before, but we're going to learn how to use it and use it to combine and use it to solve problems where we have combined stuff. We're going to learn the area formula of a circle and the circumference formula of a circle and talk about what those two things are. But I'll give you a minute to get your notes ready, okay? Okay, let me say it again. So these fancy circle people sitting around, had no internet, didn't know what to do. They sat around and they measured circles. So they got a circle, they got round things, they measure the circle, and then they measure their diameter, the circumference, and then they measure the diameter. So they made ratios, circumference, and they divided it by the diameter. And they did this for all kinds of circles. Tiny circles, gigantic circles, medium circles. And every time they divided circumference by diameter, they got a certain number. Does anyone know what number that is? Come on, take a guess. We're talking about circles here. Anyone take a stab at it? What number did they keep coming across? Did they keep getting when they got circumference and divided it by diameter when they made that ratio? And what did they always get? Does anyone have a clue? Come on. Hello? Is this thing on? Am I on mute? Guys there? Hello? What number do you think about circles, what number do you think they kept coming up with? Come on, guys, take a stab at it. We're talking about circles. When you think about circles, what do you think about? What comes to mind when you think about circles? Yes, they kept coming up with this number. 3.1415926 ... And it went on forever and it didn't repeat. And they kept seeing this number no matter what the circle was. When they divided the circumference, the perimeter, divided by the diameter, they always got 3.1415926 ... Every time. And they're like, oh my God, this must mean something. So instead of writing this long number, they said, all right, let's call it something else. And what did they call it? What did they get this number? They called it what? They called it this. That's a Greek letter, right? That's a Greek letter, which means pi. That's it. They just called it the letter pi. And they said, all right, this letter from now on will stand for 3.1415926. I don't think they spoke like that in Greece. Anyway, that's what they did. They're fancy. They came up with the letter pi. That's a Greek letter, pi, P-I. And so now, whenever you see pi, it's because it is circumference divided by diameter of any circle. So this is how we came to the circumference formula. Since the circumference of any circle divided by the diameter of that circle equals pi, if I want to know circumference, I would just multiply both sides by diameter, and I get the formula. These cancel. Circumference equals pi times the diameter. There's my formula. Circumference equals pi, 3.1415926 ... times diameter. Did you have this contest in elementary school? How many places of pi can you memorize? And then you had a competition and they had prizes. I know my sons did when they were in elementary school. No, you didn't have that competition? My son was for a week just on his bed, just looking at numbers, he just wanted to beat the whole class. He's just very competitive. And he memorized 100 places of pi. I think 106 exactly. I think it was 106. And he beat the whole class and he was proud and he was happy. I think he still remembers like 37 because he's in college. His first year of college. He's finishing up his first year of college right now. And I asked him, how many can you remember from all those years ago? He's like, I think 37 still. Like it's still stuck in his head. No, it doesn't. I'm not going to ask you to do that. It's not a skill that you need, but it is a competition sometimes that schools do, especially on Pi Day on March 14th, 3.14, get it? March. So pi is 3.14159. If you look in your calculator, you'll see a button that has pi. So if you want an exact number, you can use the pi button. Or if you don't, you can just use 3.14 for pi or 22/7 for pi. Okay, so that's fine. So when we're doing our calculations, if you want to do 3.14 or 22/7 for pi, that's fine. If you want to use the pi button on your calculator, you'll get the most accurate answer if you use that pi button because it's the entire pi. Okay. Now there's another formula. There was someone else who said, we can also call this circumference if we use the radius. Like, what do you mean? Because the diameter, isn't that 2 radiuses or radii? And that's true. A diameter is just 2 radii, right? So if I substitute circumference and put pi, and instead of d, I put 2r, and then we rearrange it, we can say circumference equals 2 pi r. And we'll get the same answer, right? Either it's just pi times diameter, or instead of diameter, I can just put 2r. 2r. And I put 2 pi r because that's the basic way you'll see it in textbooks and stuff. They put the 2 in front and the r at the end. But just 2r is the same thing as diameter, right? Because 2 radii is 1 diameter. And that's where the circumference formula came from a bunch of Greeks. And it wasn't just Greece. I know Greece gets all the credit, but it was happening all over the world where this was being discovered. Because math, again, no one invented it. It was discovered, and different civilizations discovered it at different times. But it sucks that only one civilization usually gets the credit. And it's usually the white civilization, right? Which kind of sucks. So the Greeks, they got to name it pi, their letter, their Greek letter, and then they got to hog up all the credit, even though it was being discovered in Latin America and everywhere, a whole bunch of places around the world at that time. Because math is something you discover, not something you invent. And I'm going to show you the area formula, but I'm not going to explain the origin of that. I will just tell you the area of a circle is pi times radius squared. Okay, so area of a circle is pi r squared. Okay, there's your 2 formulas. Area is pi r squared. Circumference is pi d or 2 pi r. Either one, doesn't matter. Depends on what information they give you. Okay, so I'll give you a second to copy that down or ask me any questions you have. Okay, so no questions. All right, so let's look at number 1. Let's look at so for these examples here, you have 8 problems, right? You have 8 problems. It says find the area for 1 through 4 and find the circumference for 5 through 8. So 1 through 4, they want the area. 5 through 8, they want circumference, okay? So let's look at number 1. Let's find the area. So again, area is pi times radius squared. Okay, and so that means area is pi times, what's the radius? The radius here is 12. They tell you radius is from the middle to the end. It's 12 meters. And when I square the number, I'm also squaring the units. So the area equals 12 times 144 meters squared, because you also square that. So then, did I say 12 right here? I'm sorry, that's pi. And so we can leave our answer like this. Some teachers, and in trigonometry you do this, you can leave it 144 pi meters squared. You could leave it like that. But we're not going to do that. We're going to actually get a number. We actually want a number. So if we're going to get a number, there's 2 ways to do it. We can use, so one way to do it is just say the area is 144 times 3.14. We just use 3.14 for pi. And if I punch that into my calculator, 144 times 3.14, I get the area is 452.16 meters squared. And that's fine. But if you want to be a little more accurate, you can say the area equals 144 times pi. And so if you're doing this on your phone, if you turn your phone sideways, put 144, then put times, and there should be a pi button. Hit the pi button and then hit equals, and you get a more exact answer. So the area is more exactly 452.16